Okay. So we're still continuing on with limits today, but today we're going to talk about left and right limits separately on a function, and then determining whether or not a limit exists from a graph. And so today it's all going to be still looking at graphs and whatnot. So go ahead, grab your notes, and we will get going here. That's geometry. Come on, there we go. Okay. Limits with graphs. Day 2. So the first thing we're going to talk about is left and right limits. Okay. So with left and right limits, we might see something happening like this, where we've got a graph. And it might be a piecewise function, it might not be. This one is. And we might be asked for the left limit or the right limit of f of x. And the way that we would see the notation on this, we would see the limit as x goes to 4, and then we'd see a little negative sign up in the corner, almost as though it's an exponent. This means left limit. And then if we were looking as x goes to 4 from the right, we'd see a little plus instead in the exponent, or as though it were an exponent. Like, that's kind of how the notation works. It's a superscript. So this would be a left limit. This would be a right limit. And so it's the limit coming from the left-hand side of the function that we are looking for. So it's the limit as we approach from the negative direction. And then this would be the limit, the right limit, the limit as we approach from the right-hand side or from the positive direction. So when we look at this function, the limit from the left-hand side, well, if I'm coming along from the left and I approach the x value of 4, my left-hand limit here is 1. Because that's the value that my function is approaching from the left-hand side. And then the right-hand limit, as I travel along from the right, is 3. Because that's the value my function's approaching from the right-hand side. And that's as complicated as these really get. So sometimes, like in this situation, we have left-hand and right-hand limits that are different. And we notice there is a jump discontinuity in the function. We could also see something else. This would be kind of another example. You could see something like this. And we might want the left and right hand limits as x approaches 3 for this function. So the left hand limit as x approaches 3, so as we approach 3 from the left hand side, is -1. So as I approach from the left-hand side, we're approaching -1. As I approach 3 from the right-hand side, I'm also approaching -1. So in this case, the left-hand limit and the right-hand limit are the same. So they could be the same, they could be different. which kind of nicely leads us into the next thing we want to talk about, which is whether or not a limit exists overall. So our big question now, does the limit exist? And this would be the overall limit, not just the left hand or the right hand limit, but overall, does the limit exist? So if we look at the graph from example 1, we're going to refer to that graph above again. Limit as x goes to 4 of f of x. All right. So if I have two different limits overall, I have limit as x goes to 4 from the left. I have limit as x goes to 4 from the right. Those are two different numbers. So if those two numbers are different, if the left-hand limit and the right-hand limit are not the same, then overall, the limit does not exist. So if I have just limit as x goes to 4 without a plus or a minus denoted here, this limit does not exist because the limit as x goes to 4 from the left is not equal to the limit as x goes to 4 from the right. So if your left and right limits are not the same, then your limit doesn't exist. So kind of our rule here, the limit exists the limit as x goes to a for some value a exists if limit as x goes to a from the left is equal to the limit as x goes to a from the right. So if we look at the one from example 2, and I wanted to find the overall limit as x goes to 3, we could, because the limit as x goes to 3 from the left is equal to the limit as x goes to 3 from the right. So our overall limit would be equal to those two limits because those are the same. Since these are the same, they are equal to the overall limit. Okay. And that's really everything we need to know for today. So I'm going to give you guys a couple to try real quick, and then we will move on to the assignment. And let me get a piece of paper. Okay. So there's our graph. We're going to use this graph for the whole thing, actually. So we want to know the limit as x goes to 4 from the left and the right. And then overall, if you can. If not, say does not exist, or DNE. And then we're going to do the same thing for 3. Okay, so take a moment, give those a try. When you think you've got answers for all of these, put got it in the chat. Oops, that's supposed to be -4, not +4. Goodness. As x goes to -4 from the left, or from the right, the left, and overall. All right, Aiden's already got it. All right, Jasmine's got it. Wait for a few more people here. All right, for those of you who think you have it, what'd you get for the first one as x goes to -4 from the right? What do we get? As x goes to -4 from the right. I know I switched up the order on you a little bit. All right, got to vote for 3. Anyone agree, disagree? What do we think? All right, we got to vote for 1. Those are kind of the two possibilities with 4, correct? Or with -4. So here's -4. Yeah, that could be. So from the left and from the right, this one, since it's the plus, it's from the right. So from the right would be 1. And then from the left would be 3. So yeah, I did switch up the order a little bit on you here. I went from the right and then from the left. So you might have switched them as well on your paper and gotten used to the pattern. So be sure to watch for that. But anyway, from the right-hand side, it should be 1. From the left-hand side, kind of like we discussed now, it should be 3. What about overall for this one? Does not exist. Yeah, because our right limit and our left limit are two different things. The overall limit does not exist. All right. What about the limit as x goes to 3 from the left-hand side? Yeah, 2. Because from the left-hand side, looks like about 2. How about from the right-hand side? Also 2. Yeah, this one's continuous here. So the right and left-hand side should be the same limit if it's continuous. And then overall, also 2. Okay. So on a scale of 1 to 5, 1 being I'm super confused and could use some more examples, 5 being this is super easy, why are we still talking about it? Where are we at with this one? What do we feel like? On a scale of 1 to 5. Just in the chat real quick. 5, 4, 4. All right. 3, 4. Okay. So let's take a look at some of the IXL sections we're going to be working with today together. We'll go through a couple of those problems, and then we'll go be on our way with this. So if you jump over to Google Classroom, I'm going to post it real quick, and we'll take a look together at the exact kind of questions you guys are going to see. Okay, so we have two IXLs today. One is all about finding one-sided limits, and the other one is all about determining if a limit exists or not. So there's going to be a lot of yes or no questions. So for this first one, finding one-sided limits. This one, we want the limit as x goes to -5 from the left, because we've got the minus up here in the superscript. So from the left, as x goes to -5, this function is going to -4. A lot of these are going to have these jump discontinuities here. All right, this time we want the limit as x goes to 4 from the right. So here's 4. Approaching from the right, looks like we're heading towards -7. All right, this one, limit as x goes to -6 from the right. What do we think? Yeah. So from the left, you start on the left-hand side of the function, and you move towards the value that you're looking for. So like if I was looking for the limit as x goes to -6 from the left, I would start over on the left-hand side, and I would go until I get to where x is -6. And then my answer is going to be the y value there. So the y value here is +1. So my limit as x goes to -6 from the left would be 1. And then from the right, like this one is asking, I would start on the right-hand side of the function and go until I get to the place where x is -6. And then my answer for the limit is going to be the y value at that point, which is 5. Yeah. Yeah, so you just got to pay attention to whether it's a plus or a minus. If it's a plus, you're approaching from the right. If it's a minus, you're approaching from the left. Yeah, that's partly why I switched it when we did the assignment, because I wanted to make sure that we actually got the difference and didn't just notice a pattern. Patterns are good until we're asked a question that doesn't follow the pattern. Anyway, what do we think it is for this one? X approaches 3 from the left. What's our limit here? Yeah, 7. Because as I come in from the left, we get to 7 when x is 3. Okay, so that's kind of the typical type of question here. On this one, the only thing that it switches up is it tosses the function value somewhere else. But don't let that throw you off. The limit, you're just looking for what is it approaching, not what is it actually. So for this one, approaching -9 from the left would be 5. Okay, and then the other section you guys have is determine if the limit exists. So on this first one, does the limit as x goes to -1 exist? Well, the left limit and the right limit are both approaching the same value, so we would say yes. And the actual limit then is 0 because that's the y value of what the left and the right-hand side are both approaching. All right, this one, same thing. As x goes to 4, the left limit is 1, the right limit is also 1. So our answer is yes, and our limit is 1. Come on, show me one where it's okay. As x goes to 7, though, for this one, we have a discontinuity. The left limit is 3, the right limit is 4. Since our limits are different, we just say no. The overall limit doesn't exist. All right, what about this one? Does the limit as x goes to 5 exist? What do we think? Yeah, it does. And what is it? As we approach from the left, as we approach from the right, we've got the same value going. It is 6. Close. The x value is 5. So then the y value, we want the y value that happens. Oh yeah, it is kind of, yeah, probably is kind of hard to see the graph here. If I can zoom in a little. All right, and then this one is continuous. As x goes to 0, it crosses 0, 0. Anyway, these are all the same kind of questions that you're going to see overall on the IXL for today. At this point, if you would like to go and work on your own, you are free to do so. If you have questions about either the assignment or you want to go over more examples or anything like that, feel free to stick around and ask. Otherwise, have a wonderful day.